Hello everyone, my name is Angie Murillo and together with my partner Christian Suarez, we're going to talk about the seed theory, Venn diagrams, and probability. First, let's start with the basic. What is the seed? A seed is a simple group of elements, also called objects, that have similar characteristics. For example, numbers, letters, shape, or even fruit can be for a seed. Seeds are always represented with capital letters like A, B, or C, and the elements are enclosed in brackets. For example, the seed A equals 1, 2, 3, 4, 5. A closer example, the seed of vowel in Spanish. This seed would be B equal A, E, I, O, U. If we say that A element B the seed of vowel, or means that the letter A belongs to and the seed of vowel. On the other hand, N element B means the letter M doesn't in this group. Now let's talk about two ways to describe a seed, by extension and by comprehension. Extension consists of reading down of the element that complete it. For example, A equals A, E, I, O, U. On the other hand, comprehension doesn't list them, but rather describe uncommon characteristics. In this case, it would be A equals X, saying X is a vowel in Spanish. In set theory, we use some case symbol. The first symbol means belong to. The second symbol means doesn't belong to. The third branch are used to write seed. Fourth representing the empty seed. And finally, means that the one seed is a success of another. For example, if A equals 1, 2, 3, 4, 5, and B 3 and 4, then B succeed A because of the element of B are inside A. Let's move on the operation between seed. The first is onion. The onion of two sets A and B is represented by the symbol U and means union of the elements that are in A, B, or both. For example, A equals 1, 2, 3 and B 3, 4, 5. The union will be A union B is 1, 2, 3, 4, 5. In second operation is intersection, represented by the symbol with the use M. The intersection of two sets in the set of elements that are in A and B at the same time, following the same example. A equals 1, 2, and 3, and B equal is 3, 4, and 5. Their intersection will be between A and B is a 3. Is a common number.
A warm greeting. Today, we will cover a very interesting topic in mathematical logic, the Venn diagram. First of all, let's talk about the definition of what a Venn diagram is, and later we will see what they are used for. So, what are Venn diagrams? They are graphs that show sets of elements using circles, and they include all possible elements inside a rectangle called the universe. For example, in this case, the circle on the left would be set A, which can represent anything. On the right, we have set B, and remember, all possible elements are represented inside a rectangle. This rectangle always represents the universe. What are Venn diagrams used for? They help us visualize how sets behave when there is an intersection between them. For a better understanding, here we have a Venn diagram with two circles, because I will be working with two sets, okay? Set A represents the divisors of 12, and set B represents the divisors of 15. The universe includes the number from 1 to 15. I will be very carefully to place in the intersection only those values that both sets share. So, in this part, I can place the values of A, okay? In this part, the values of B, and only in the overlapping section, I will place the values that both sets have in common, right? For example, in set A, we have the number 1, but the number 1 also belongs to the set B. That means that 1 goes in the intersection of the two sets. Now, we have the number 2. I see that it belongs to the set A, but not to the set B. So, 2 goes only in the set A. Then, I see that 3 belongs to the set B as well, so it also goes in the intersection. The number 4, 6, and 12 belongs only to the set A. Now, let's continue with the set B. We already placed 1 and 3 in the intersection. So, here I only add 5 and 15. Now, we have all the values for the each set. Okay? Set A contains 1, 2, 3, 4, 6, and 12. And the set B contains 1, 3, 5, and 15. Next, I will place the numbers in the universe. For example, number 7 is not in either of the two sets, which means I will place it somewhere else, inside the rectangle, but outside of the both circles, okay? And I will do the same with all the remaining numbers in the universe. So one of the main purposes of Venn diagrams is to clearly see the intersection of both sets. Remember, the intersection is made up of the values that the two sets have in common. In this case, the intersection of this Venn diagram is the number 1 and 3. Now we have Venn diagram with 3 sets. In this case, we must be very careful with the intersection of each set, okay? For example, we see that the number 1 is the only value that belongs to the all 3 sets, so it is placed right in the middle of the diagram, okay? The number 2 belongs to the set A and the set B, but not to the set C, which means it goes in the intersection of A and B without touching C. The same happens with number 4, since it also belongs to A and B but not to C. We see that the number 3 belongs to the set A and set C but not to set B, which means it goes in the intersection of A and C. The numbers 6 and 12 belongs only to set A. The number 8 belongs only to set B. And finally, the numbers 5 and 15 belongs only to set C. There are also several problems that can be solved using Venn diagram. For example, in a class, 15 students play soccer, 10 students play basketball, and 5 students play both sports. How many students played at least one sport? So, we can see that in this problem we are given some data that we must represent in a Venn diagram. Okay? And we are also asked a question to solve. This example is ideal because it has two clear sets, for example, soccer and basketball. Yes, it allowed us to show the intersection, the students who plays both, right? And it can be calculated very easily using the union. For example, 15 plus 10 minus 5 equal 20 students. And then we have the probability in Venn diagram. What is a probability? It's simply the part of the total that satisfies a condition with if a set or several sets represented in the diagram. Okay, we have here a simple example. In a group of 20 students, 12 study mathematics, 8 study physics, yes, and 5 study both. And the question is, what is the probability of choosing a student who studies mathematics or physics? Simple. We calculate with Venn. The formula is M union F equal M plus F minus M intersection F equal, to understand better, um, 12 plus 8 minus 5 equal 15. And then we apply the probability formula. E, yes, M union F equal 15 divided by 20 equal 0.75. So, in conclusion, probability in a Venn diagram is found by counting the elements in the region that corresponds to the condition being asked and dividing them by the total. And that's it. Thank you.